So our next topic in chapter 6 is residuals. And residuals go hand in hand with scatter plots. So we started with bivariate data yesterday, data that has two variables. Looking down at example 1, it's talking about the variable of how many times did they go to a study session versus the other variable, what score did they make on the test. And what we did yesterday was make a line of best fit in order to predict new outcomes based on the previously observed data. We want the best fit model to make reliable predictions, to give us an idea of, hey, the average person, if they go to 5 study sessions, what are they going to make? Or if they go to 8 study sessions, what are they going to make? That's the whole point of a line of best fit. One way to tell if we have a reliable prediction, though, to see if that line of best fit really fits the data, is to calculate what are called residuals. Guess what letter we use for the word residuals? You'd think R, right? Weirdly enough, it's not R, it's the letter E. Why? Why do you think it's E? Because a residual is just the error. E really stands for error. Between what is observed in the actual data set, what these people actually made on their test, versus what the line of best fit would have predicted. So it's just how far off is that line of best fit. So I've gone ahead and done some of the work for us here. This example, we've got people who had gone to different numbers of study sessions and the test score that they made. I've made the scatter plot, and I went ahead and drew the line of best fit, but we're going to need to pull up the numbers in our calculator. One thing that I need you to do is definitely reset your calculator with that second plus 712. Otherwise, there's a setting that my first and second period, both of us, we switched on, that I need you to switch it back off by resetting your calculator so you can see how to get there. Otherwise, your stuff is going to be really confusing here for a little bit. So again, reset your calculator, second plus 712. And then we're going to type in all of these data values in stat edit. We're going to type in all of the numbers of prep sessions in one column, and the next column is going to be all the test scores. In total, you should have 11 people's information typed in. Again, in total, you should have 11 people's information typed in. And then once we have those 11 people's information typed in, stat calc. Again, when you go back to stat, go over to calc and select that fourth option, lin reg. Go down to calculate. And we should have these numbers, 7.653846154, 13.03846,154. Let's just round that off to 1 decimal place each. Sound okay? So A, I would round that off to 7.7. B, I'm going to round that off to just 13 even. Anybody need help getting there? Okay. So, moving on down. That tells us that the function y equals 7.7x plus 13 appears to be the best model for this data. But I want to calculate the residuals, the error, and that's going to take two big steps. To calculate the residuals, subtract the observed minus the predicted. By observed, I mean what actual score did these people get? And by predicted, I mean what does this line of best fit, y equals 7.7x plus 13, tell us they should have gotten around? So, going back up to this table, that next blank column, I'm going to write predicted. And I'm going to use that function y equals 7.7x plus 13 to figure out, based on these number of prep sessions, what should they have made on that test? Now, the long way of doing this part is typing in 7.7, plug in 7 plus 13. 7.7, plug in 6 plus 13. That's the first two numbers that I need. And you can totally do that, but there is a quicker way. In your calculator, if you go to y equals, and in that y1 type this in, 7.7x plus 13. The x button is right here beside alpha. And then hit second graph. It'll take you to a table that's got them all plugged in for you. So again, in the y equals menu, I typed in 7.7x plus 13. And then I pressed second graph to go to the table. That table has every possible answer of what I could plug in for x. So like the next one for Carmen went to 3 prep sessions. I see the ordered pair 336.1. I also see that Louisa went to 3 prep sessions. That would have also said she's predicted to make a 36.1. We can pretty easily fill in the rest of this column. Carter, who went to 10 sessions, should have made around a 90. He actually made 100. The whole point of residuals is saying how far off is this line? This line of best fit, how far off is it from the actual data points? How we're going to find the residuals is just subtracting. So in the next column, I'm going to write residual. And the letter E. And then this one, you just have to type it out in your calculator. You're going to subtract for Adam 80 minus 66.9. Type that in, you get 13.1. What that means is Adam, who scored an 80, scored 13.1 points higher than what would have been predicted by this model. The next person, Brett, who studied or made a 75, 75 minus 59.2 is 15.8. So he scored 15.8 points higher than what would have been expected. The next person, 20 minus 36.1, is negative 16.1. What that means is Carmen actually scored 16.1 points lower than what would have been expected. So just keep on subtracting these. I've already got all those numbers for us up here. So visually, the residuals, if you look at the scatter plot, are the actual distance from the point either up or down to the line. Like this point 110, that shows that Gabby scored 10.7 points below what would have been expected, and so her point is 10.7 points below that line. Each of these residuals is just how far above or below these are. The closer the point is, the less the residual. And you can see, like for this point, Meg, who studied for 9 hours, or excuse me, went to 9 prep sessions, but only made a 40, that's going to be a really big residual, because that point is really far away from the graph. Can you imagine Meg and Sue, they went to 9 prep sessions each, how Meg is feeling making a 40? And our friend who also went to the same 9 prep sessions made a 95. Poor Meg. Tough day. Speaking of Meg, her score just seems kind of different, right? Just kind of doesn't fit with the rest of the data. That's making me wonder if my line of best fit might not be the best line of best fit. Kind of a weird thing to say here. So what I want to do next is a measure of reliability of the line of best fit is called the correlation coefficient. Correlation spelled C-O-R-R-E-L-A-T-I-O-N. Coefficient spelled C-O-E-F-F-I-C-I-E-N-T. Guess what letter we use for correlation coefficient? This is where R is. It feels so silly. We don't use R for residual, but we use it for correlation coefficient. I don't know why. I missed that meeting back when, stats was invented. So this number, the correlation coefficient, whatever R is going to tell us how good our line is. Now, the number that we get for it is always going to be between -1 and +1. The closer to +1 it is, the more strongly positive. The correlation is, and likewise, the closer to -1, the more strongly negative. And then the closer to 0, whether that be like 0.1 or negative 0.1, the closer to 0 that is, the weaker the correlation is. I want to reference back to a picture I showed you in your notes yesterday. These different types of correlation, this perfect positive correlation would have an R value of 1. Then this would be like 0.8, and this would be like 0.5. The no correlation would be 0. And then so on. The weak negative would be like negative 0.5, negative 0.8, and then R equals negative 1. The nonlinear correlation, you're going to see similar to the no correlation of R is around 0. Okay? So, here's how we're going to get that R value. Back in your calculator, we should still have all these data values typed in. What we need to do is turn on a specific feature in our calculator that's going to give us some additional information. How we're going to do that? Press second and then 0 to go to our calculator's catalog. So the blue second button, and then 0. That should take you to this screen that says catalog. This is a list of literally everything your calculator can do. Then we're going to scroll down until we see a feature called Diagnostic On and press Enter. So just scroll down, a bunch of weird looking stuff here until you get to the D's. It is in alphabetical order, and you're looking for Diagnostic On. Hit Enter, and then Enter again, and it'll say Done. All that was is just flipping a switch on our calculator saying, hey, when I run a linear regression, tell me this additional information. I'm going to run you back through that one more time. With all that data typed in, I pressed second 0 to go to the catalog. Then I'm looking for something called Diagnostic On. Because that starts with a D and this is in alphabetical order, if you look at this button, the X to the negative 1 button, it does have the green letter D above it. If you press it, it'll automatically take you to the D's. What's what supposed to do? I'll show you in just a second. Once you find Diagnostic On, hit Enter, and then Enter again, and it should say Done. So now, we're going to go back to our linear regression. Stat, Calc, fourth option. And when I hit Calculate, it's going to give me the same A and B, but then 2 more numbers. And I want to write those in. Usually for these numbers, we round to 3 decimal places. So R squared is 0.630, and R is 0.794. So you may be thinking, what do these numbers mean? What's so special about them? This bottom number, that tells us how good our line is. And essentially, it basically means that our line is about 79% accurate. Does that feel good? 0.7937 rounds off to 0.794. So that says that we're about 79% accurate. Honestly, not great. You want this number to be as close to 1 as possible so that your line of best fit is fitting the data better. So one of the things that I mentioned is that Meg, weird little Meg, she studied for 9 sessions, but she only made a 40. Looking at the scatter plot, she's way away from that line. So looking at the back of our paper, just like with univariate data, we could have an outlier. Yes, sir. Can you wait a little bit? So I'm already feeling that Meg is an outlier, and a good rule of thumb for whether there's an outlier in a scatter plot is just whatever has the largest residual. Looking back at our table on the front, the one that had the largest residual was definitely Meg. She was 42.3 points off from everybody else. Okay, so what we're going to do is cross out Meg. Just like with an outlier in single variables, it messes up the mean and the standard deviation. Here, it's messing up our line of best fit. So, what we'll do now is in our calculator, go back to stat edit, back to that original data. Meg studied for 9 hours and made a 40. Is that right? Yeah. We're going to go down to the 940. Then very carefully delete just the 9 and delete just the 40. Be careful because the next x value is 9. When you delete the 9 and the 40, you now should only have 10 people's information typed in because we tossed out Meg. And now, stat calc fourth option. We're getting a new line of best fit. And it gives us these numbers. Now, I usually say round to the nearest one decimal place more than what's in the data, but since this already just cuts off, let's just leave it as 9.75 and 6.75. For r squared, we've got 0.887. And for r, we've got 0.942. So what's the big deal with all of that? Do what? That last number, r. Originally, it was 0.794. Now it's 0.942. What that essentially means is our line used to be only about 79% accurate. Now it's about 94% accurate. It's a much closer fit. So without Meg's information, the line y equals 9.75x plus 6.75 fits this data better. Anytime you see the R value go up, that means that your line of best fit fits better. R squared, we're going to talk about him tomorrow. That means something else. It's called the coefficient of determination. That just basically tells you, should we be using a linear function versus like a quadratic or exponential? So, bottom line is, whatever has the largest residual, we consider that an outlier and toss it out. Recalculate. Anytime you recalculate after tossing out the largest residual, you're going to see that R value goes up closer to 1 or down closer to -1, meaning it's a better fit. We're not going to do this, but also if we went back to the front page and completely redid this table, meaning recalculated these predicteds and recalculated these residuals, we would see that every one of these residuals goes down. Okay? I'm not going to make you do that. Just trust me on it. Last thing I've got for you is 3 just EOC style questions that have to do with residuals. Can we tackle those and then be done? Cool. Number 1, the best fit linear model for a certain set of data is found to be y equals 1.25x plus 15. So they didn't give us the data. We didn't have to type it into L1 and L2 and do a linear regression. It just gave it to us. But one of the points in this data set is 317. What is the residual for this point? So, what I'm going to do to answer this question is take this 3 and plug it in for x. I don't even know what the data means here. Let's just say it's talking about how many hours somebody studied in their test score. This says that someone studied for 3 hours and they made a 17. This function is supposed to tell us what they should make based on how much they studied. So let's plug 3 in. $1.25 times 3 plus 15 comes out to 18.75. To figure out that residual, you're always going to subtract the observed minus the predicted. Meaning, this person actually had a 17, but this function says they should have had an 18.75. Subtract that, you get negative 1.75. The answer is B. Whatever this data means, that means the person who had 3 and got 17 from it was 1.75 below whatever. Feeling okay about number 1? Okay, number 2. The table shows the amount a catering company charges, Y in dollars, based on the number of guests served, X. Does that make sense that the number of people you serve is going to influence the cost? Okay, we've got this table here. 12 people cost $194, 16 people cost $218. The question is, as determined by the best fit linear model, which Y value is furthest from its predicted value? So the first thing I need to do, find that best fit linear model. That's that thing where I put the stuff in the calculator and get Y equals AX plus B. Luckily, it's a smaller set of data. Everybody with me? So I'm going to go back to stat edit. Now, y'all, you can reset your calculator with that second plus 712. It will turn that diagnostic thing back off. So later in the worksheet that you're working on, you're going to have to turn it back on. What I'm going to do is just highlight L1, hit clear and enter. Highlight L2, clear and enter. Don't hit delete. You want to have the L1 and L2 labels up here. And then I've got just 5 points to type in. What's up? Hang on just a little bit, okay? Okay, run stat calc fourth option. And if I run this off to the nearest tenth, we get the function y equals 4.4x plus 144.3 is our line of best fit. And because I have those diagnostics turned on, I see r equals 0.9978. That means that this line fits extremely well. But that's not the point of this. The point is actually saying which y value is furthest from the predicted value. So it's only given me 4 options, 218, 225, 250, and 320. So I'm really just looking at these 4. So what I need to do now is compare. When I plug in 16, how far off is what I get from 218? I'm going to type in 4.4, plug in 16, plus 144.3. Comes out to 214.7. To figure out how far that is, just subtract 218 minus 214.7 gives us a residual of 3.30, meaning this group paid $3.30 more than what would have been expected for a party of 16 people. Just to make this go by quicker, by plugging in 18, you get 223.5. Subtract that to get your residual of 150. Plug in 25, you get 254.3. Which gives you a residual of negative 4.30. Meaning this group actually saved $4.30 instead of overpaid. The last one, plug in 40, you get 320.3. You subtract that, you get negative 0.30. Ignoring the positives or negatives, which of those numbers is biggest? C. That's it. Even though it's negative, that's the largest residual. Any questions on that, y'all? Okay, last one, just to make this a little bit quicker. Pretend that we went in, cleared out our data, and typed in these 5 points. Ran a linear regression. We get y equals 1.3x plus 7. Now the nice thing about number 3 compared to number 2 is I don't have to test a bunch of stuff. It wants to know the approximate residual at x equals 39. So I'm just looking at this line in the table. The observed value is 61. But let me find that predicted value by plugging 39 in for x. It's going to come out to 57.7. When you subtract that, you get 3.3. 61 is about 3.3 points above 57.7. You have to think of, wait a minute, where's the answer? The answer is, I made a typo. D should have actually been 3.28. My fat fingers hit the 2 instead of the 3. So if you'll just change that to a 3.28, circle D, D should be the right answer once you fix the typo. 3.3 is essentially 3.28. How are we feeling? Okay. Y'all, I need you to look up here real quick. This next paper I'm going to give you, on the front is a group of people, how many books they read their 3rd grade year, and the score they made on their 3rd grade reading EOG test. I've already drawn the scatter plot. Looking at number 1, determine the equation. That's where you're going to type all of these in, run a linear regression. Guys? Number 2, to the nearest thousandth, what's the correlation coefficient? That's going to be just this number, whatever it comes out to be whenever you type in those kids. 3 and 4, you're going to go back up to this table and fill in. Once you get your equation, plug in 6 and 4 and 8 and 10 and get these numbers. And then subtract the score minus the predicted to get the residual. Then going back down here, which student's data value appears to be an outlier? How do you know? Do you see what looks like it might be an outlier on this graph? Probably that one right there. Yeah. So it's going to be pretty easy to identify what the outlier is, but I do want you to explain how you know. You'll see it 2 ways. 1, it sticks out, and 2, the residual is going to be pretty big. Remove the outlier value and rerun the linear regression. You're going to get a new y equals mx plus b. You're also going to get a new r. The r is going to change somehow, and I want you to tell me what that change means. On the back are 3 EOC style questions. Just answer them as best as you can. Let me know if you have any questions. Any questions before we get started, y'all? You're welcome to work with a partner, move around the room. Just make sure you're actually working well with that partner. All right, y'all, let me know if you need help.